Hello everybody, Sandre here. Now this segment is going to be a specific segment of Debunked where I focus exclusively on flat earthers. In this first installment I'm going to talk about the replacement of gravity that flat earthers believe in, because in order to preserve their idea of the flat earth, they have to reject everything we know about gravity. Now, unlike what you may think, there are actually several different camps of flat earthers, and many of them believe in their own replacement of gravity. Some believe that gravity is simply just a form of magnetism. Others believe that things simply fall because of density, whatever that's supposed to mean. Others believe that the Earth is kind of like an atomic model, and, well, I'm going to get to that. Anyway, let's start with their first explanation. Dielectric acceleration. According to this explanation, objects simply fall because there's a difference of electrical charges between the ground and the sky. Now, during certain circumstances, there can definitely be a charge difference between the ground and the sky. This is why you have lightning, for instance. The problem is, in other places in the universe where you actually have those kind of extreme circumstances being quite common, you have lightning strikes all the time. If charge differences between clouds and the ground was the explanation for why things fall, obviously it's not, but even if it was, why don't we see lightning strikes all the time? Besides, you do realize that in order for this to work, there's also another problem. Take the human body. We are not specifically polar in any way. Whatever part of the human body you measure, you have about as many positive charges as negative charges, which means that any electrostatic force that would try and force us to the Earth's center— oh, I'm sorry, I was talking as though the Earth was round again. I'm sorry, I didn't mean to trigger you, but any electrostatic force that would force us down, whatever direction that is, it would have to rely on a charge difference between the human body, for instance, being either very positive or negative, and the ground being very positive or negative. The problem is, this electrostatic difference just doesn't exist. We can make things move based on their charge alone with special equipment. However, these require a lot of energy and very high electrical charges to work. Even if this mechanism could be proven to work somehow, what would end up happening is we would always be struck by lightning, and we would essentially get electrocuted whenever we, well, just tried to exist. So dielectric acceleration just doesn't work as an explanation, period. How about magnetism? Could magnetism explain gravity? No. For this one, I'm not even going to bother give any in-depth explanation. Rather, I'm just going to ask you a simple question. If us being attracted to the Earth in a direction that you would proclaim to be down, if that is magnetism, then what exactly is this? We already know so much about electromagnetism and how it works that we understand what kind of material is very ferromagnetic, let's say, or paramagnetic, or diamagnetic. Yes, I don't know if you guys know, but there's different types of magnetism. So my second question here would be, well, what type of magnetism is it? You guys would actually have to demonstrate a new type of magnetism that we didn't know of. And I'm not holding my breath that you guys are going to succeed. We already understand the mechanism of magnetism. We know why it arises. It fundamentally has to do with the spin of electrons and certain arrangement of electrons in orbitals around atoms and molecules. In fact, our understanding of magnetism is so good that it's shared in both physics and chemistry. Yes, our model of magnetism is so good that we have two completely different natural sciences with fundamentally different models of how the world works still agreeing on magnetism and its causes and implications, and both natural sciences can use the same model of magnetism and make perfectly accurate predictions, whether it is to predict electronic states of atoms in chemistry, or it is to predict the field strength of a magnetic field in physics. In order for you guys to get away with saying that gravity is simply magnetism, I mean, you would have to chip away at everything we know about magnetism and demonstrate a new type of magnetism that we've never observed before. But the thing is, this phenomena would have to be so fundamentally different from the magnetism we know that it wouldn't even really be magnetism anymore. Anyway, let's jump to the next explanation. Density. Objects fall because we are denser than other objects around. Okay, let me ask you a question here. We all understand density on some intuitive level. Let's say that you're in a swimming pool. In one hand you have a bowling ball, in the other you have a beach ball. Put both at the surface of the water and see which floats. The answer should be pretty obvious. Naturally, the beach ball is going to float and the bowling ball is going to sink to the bottom of the pool. Why? Well, because the bowling ball has higher density than the beach ball. Basically, there's simply more mass per volume unit in the bowling ball than you have in the beach ball. If an object is put in a medium and the medium around the object has less density than the object, it's going to sink. If it's the other way around, it's going to float. We all understand this, right? Now, my question to flat earthers is, why the fuck is it that we always observe the same kind of movement in the same direction? I mean, seriously, why is it that you always observe the same direction of the buoyancy force in any calculation? The only way for this to make sense is if the buoyancy force is working against another force in the opposite direction. Yes, the concept of buoyancy, and hence density, only makes sense if you have a force acting against the buoyancy force, and fundamentally if you have a force acting against matter or mass in general. If you guys had simply just paid attention to your high school physics class, you would realize that the buoyancy force always works in one direction because it's fighting another force. We call this force gravity. The gravitational force is always opposite to the buoyancy force, also known as the normal force. Why is this? Why is it that when you're standing in the pool, you're constantly being pushed down, but the beach ball wants to go up in the exact opposite direction from where you're being pulled at? Density doesn't work as an explanation for gravity because, well, it's inherently dependent on a force like gravity. Basically what I'm saying is, if buoyancy and density is your alternative to gravity, well, you always have less dense air around you. Why don't you ever fall up or sideways? Also, let's take a look at this formula for buoyancy. You're going to notice that it has the incorporation of a little g, which is the gravitational constant. Yeah, mathematically speaking, and so fundamentally speaking, buoyancy doesn't work. It just doesn't work without gravity or some kind of force like gravity. And unless you guys can come up with an entirely new mathematical model without the little g, no one should or even can take you guys seriously. Now let's take a look at another alternative of gravity. Now these types of flat earthers believe that the earth is kind of like a giant atom. Basically their reasoning tends to be that we understand how atoms work in the Bohr model, basically that you have electrons in a circular orbit around the nucleus. That somehow can be translated to the entire Earth, and that objects fall down to Earth because they're like neutrons and protons, and the sun somehow would be like an electron. Yeah, this doesn't make any fucking sense. The fundamental problem here is we know that what is responsible for the organization of atoms is the strong nuclear force. And the problem is we know that this force has a certain range. You go outside of that range, things fall apart, literally. Ever heard of radiation? Yeah, that's because of the weak nuclear force. That's because you get out of range from the strong nuclear force and the weak nuclear force takes over, and that's responsible for radiation. I mean, even if we assumed that your model somehow could be upscaled, which it fundamentally can't, but even if we assumed that to be the case, we would all pretty fucking quickly die from radiation poisoning, even without being close to any of the naturally radioactive heavy metals in the periodic table, because we ourselves would be radioactive. Anyway, now we get to the dumbest explanation of all, in my opinion. The Earth accelerates. Okay, listen closely. I'm sure a lot of you have heard of the idea of gravity by Einstein. Let's say that you're out in space. You will be weightless, right? Well, let's keep you in space, but let's put you in an elevator. And let's start the elevator going upwards in its shaft. And let's say that we constantly accelerate this elevator at 9.8 meters per second squared. All of a sudden, you wouldn't feel weightless anymore. In fact, it would feel pretty much just like Earth's gravity. And had you not known that you were out in space, you would probably assume that you're just in an elevator shaft on Earth. Now, the same principle applies to gravity. The reason you feel heavy is because the force of gravity is always working on you. And had you been in free fall in a perfect vacuum, you would have accelerated towards the Earth's center at about 9.8 meters per second squared. Now, you don't constantly accelerate towards the Earth's center because, well, you have matter between you and the core of the Earth. However, if you jump up over the surface of the Earth, you will quickly find that you will accelerate downwards again. Again, because gravity is constantly working on you. However, flat earthers are indeed correct that you can simulate gravity in a sense by simply accelerating someone at about 9.8 meters per second squared. Now, the way the flat earthers explain gravity is that the Earth is simply accelerating upwards, whatever direction that would be, at about 9.8 meters per second squared. Well, I find two big problems with this idea, and I'm going to start with the lesser of those two problems. You see, the Earth's gravitational constant isn't exactly 9.8 meters per second squared. In fact, it's not entirely the same anywhere on Earth. If you stand at the south or north pole of the Earth, you will find that the gravitational constant is about 9.82 meters per second squared. But if you stand at the equator, you would find that it's about 9.78 meters per second squared. How the hell do you explain this very slight but noticeable difference in the gravitational constant on a flat Earth? You can't. The only way this slight deviation makes any sense between the gravitational constant of the Arctic and of Costa Rica, let's say, is if the Earth is round. Why? Well, because you have the centrifugal force. You see, as the Earth is rotating, if you stand on the Earth's equator, there's going to be a slight normal force working against the force of gravity, wanting to pull you out into space. Again, this is just simple physics that everybody should understand. If you spin a rubber ball very fast, you're going to notice that the equator of the ball, like the midsection, is actually going to be a little bit bulged compared to the top and bottom of that ball. This is because of a force working against the inherent force of the material wanting to keep it a sphere. Now, the second problem, and the biggest problem I find with this supposed explanation for gravity by flat earthers, is that, well, you see, if the Earth was constantly accelerating upwards, whatever direction that is, it would eventually reach the speed of light. Yeah, see, that's the thing about acceleration. It means that you're constantly going faster and faster and faster. That is what acceleration is. And we all know you can't go faster than the speed of light, so at some point, in order to preserve this very basic law of the universe, the Earth would have to start to slow down again. At that point, your explanation just doesn't work anymore because, well, we would start floating now, wouldn't we? Because your explanation would only work if the Earth continued to accelerate ad infinitum, which of course is impossible. In fact, the Earth would reach the speed of light in just about 354 days. In other words, in less than a year. Besides, what is it exactly that would exert this force on Earth to make it move and constantly accelerate like that? Not only is this idea silly because of deviations in the gravitational constant that we can measure at different parts of the Earth, and not only is it erroneous because, well, you would eventually end up at the speed of light, which is impossible, and eventually go faster than the speed of light, which is even more impossible, but you haven't even explained what exactly is exerting this force that makes the Earth accelerate in a certain direction to begin with. Alright, anyway, that's gonna be enough for this video, and I hope you guys enjoyed it. Take care. Bye!